Today I'm going to solve 5-position synthesis problem as if it is 4-position synthesis problem and determine the intersection of those Burmester curves. Here I have 5 positions. We have to treat, first of all, this problem as if it is 4-position synthesis problem. I'll take 1, 2, 3, 4, solve it as explained in chapter 4. I'm not going to, I'll simply go over it very fast. And then we are going to solve 1, 2, 3, 5 and determine the intersections. Now, 1, 2, 3, 4 is all I have already available over here. This is positions 2, 3, 4. And 30, 40, 60, 0, x values, 30, 50, 70 are the angles for positions 2, 3, 4. Position 1 is 0, 0, normally. Now, these are the circle point curves and center point curves. M is for center point, K is for circle point, for positions 1, 2, 3, 4. I'm not going to repeat the same thing for 5. All I have to do is click over here, move or copy, create a copy. Here I have a copy of this same sheet available. I'll rename this as, rename 1, 2, 3, 5. And all I have to do is change delta 4 to delta 5, alpha 4 to alpha 5, and refer over here, 80, 0, 90 degrees. 80, 0, and this is 90 degrees. As you can see, the circle points and center points change. Now, if you are careful, all you have to do is change this to 5. 1, 2, 3, 5 it is. Now, in order to determine the intersections, you don't need both of these curves. All you will need is either circle point or center point. It doesn't make any difference. We have to determine the intersections. So this time, what I will do is I will select the center points. What I will do is sheet 1, I'll rename it as center point curves. Over here, I will insert with points. Do not use line or other form because plotting point by point is much more. I can move this way. I will take this graph as large as I can. Now I will select data. First, I will go to 1, 2, 3, 4. I'm going to use center points, so it will be R values. I will select first corresponding to beta 2 and beta 4, 1. Control Shift Enter all the X values I have entered. I think I did something wrong. No. Deleted. Select data. Yes, I think I selected something wrong. Go to 1, 2, 3, 4. I select center point, R1, Control Shift enter. Now, Y values, Control Shift, enter. That's the first part of center point curve 1, 2, 3, 4. Okay. Add 1, 2, 3, 4. R2, Control Shift, enter. Control Shift, enter. Okay, okay. Let me click OK. Since the chart goes from minus infinity to plus infinity, both in X and Y directions, we don't see anything. So let us select minus 10 to 70. Of course, you can change these. 10. Minus 10 to 70. This portion is enough. If you want, you can, increase the chart, maybe make it 100. You do it like that. Let's see how easy. Okay, I think it's okay. I don't have to go all the way up. Now I will change these colors. Marker options, build-in, make it smaller. Solid fill, I'll make it red. And solid line, make it red. Okay, again this one. Marker, build-in. I think I should decrease the size as well. Not that much, okay, this is good enough. Solid fill, red. Solid line, red. This marker I have to okay. Here's the looks not bad. Next, over here, I will select a point, add data label. This is going to be M1, 2, 3, 4. Okay. Next, I will select data, this time 1, 2, 3, 5. Add. I don't understand why select data, add. Center point, Control Shift Enter. Y component, Control Shift Enter. Add 1, 2, 3, 5. Control Shift Enter. Control Shift Enter. Here we are. Now again, let us format data series. Marker options, built-in, decrease its size. Solid fill. This time let us make it blue and dark blue. Solid line. Dark blue. Okay. Marker, built-in, solid fill, dark blue, solid line, dark blue. Okay. Now you can see the intersections, etc. Now we are to find those intersections. Let me move it over here. Here I have the, okay, yes. Now what I'm going to do is, I will simply select these two lines, Control C, go over here, Control V. Of course, it is not correct, but let us see. This is 0. Let me take it 5 degrees. That's in radians. First of all, I have used Burmester to determine those points. Oh, see, I have to move these. This, and alphas in radians, like this. Control Shift, Enter. Those are the angle values. I can check it in a minute. I will do that. I'll mark these cells. Again, I have a problem. Okay. Control Shift. Notice it uses beta for 1, beta 2, and beta for 1. Control Shift, Enter. Now I will do the same over here. Move alpha 2, alpha 2. Notice it uses beta 2 and beta for 2. Control Shift, Enter. That's it. This is for positions 1, 2, 4. 3, 4. Now, I'll copy these cells, Control C, go down, Control V. It is the same thing, but this time what I will do is this. Mark these cells. Instead of 4, move it 5. Control Shift, Enter. And then Control Shift, Enter. Control Shift, Enter. I have two solutions. Now, what I will do is this. Is equal to this value. Beta 2 will be the same for 1, 2, 3, 4, and 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 5. Okay? If one has coordinates z1 or r1, the other is going to has to have the same coordinates r1 because they refer to the same reference axis, which is the first position. Now, what I will do is there are 4 distances between these points. When beta 2 is the same, there are 4 distances. One is I'm going to determine the distance between 2 points corresponding to the same beta 2 value. By the way, these angles, Control C, Control V, although these angles correspond to beta 4.1, beta 4.2, these angles are not the same. These angles correspond to beta 5.1 and beta 5.2. Because it is not the 4th position, it is the 5th position. So these need not be the same, but beta 2 has to be the same. So what I do is, I determine 2 distances corresponding to the same beta 2 value, 2 distances between 2 center points. One is SQRT, open up parentheses, this value minus this value plus, open up parentheses, this value minus this value squared, close parentheses. This is the distance between those 2 points. It's quite large. Another one is equal to, or I think I can, if I copy it, Control C, copy it to the same place, it will be the same, I think. Yes. However, there are 2 other possibilities. One center point can be in this branch corresponding to beta 4.1. The other can be in the second branch corresponding to beta 5.2. So I have 2 more. One is, let me type over here, is equal to SQRT, open up parentheses, this value minus this value plus, order is not important, this value minus this value squared, square root. That's another distance. The 4th distance is SQRT, this value minus this value squared plus this value, or open parentheses, minus this value, close parentheses, squared, close parentheses. Now I have these 4 positions. When they are equal to 0, that's the solution for 5-position synthesis. What I have to do is I have to change beta angle, but I have to be more precise than that. What I do is I go to the developer, I insert I'm not going to insert only one, Control C, Control V, Control V. I'm going to have 3 of them. This one will be the main one. Properties, it will correspond to A13. Of course, you can change it to some other cell. Maximum is going to be 360. Minimum is going to be 0. And it will small change, it will be incremented by 1. Okay. This will be linked to A14. It will be from 0 to 100. And this will be linked to A15. It will be from 0 to 100. Okay. Now, for the closed diagram, let me simply place some values over here. What I will do is this, is equal to this value plus this value times 0.01 plus this value times 0.0001, 10 to minus 4. Now, what will happen is I can change it by 1 degree, keep these 0. As you can see, these values will be increasing or decreasing. Let me do it this way. Oh, here it says, let me go this way. Still decreasing, 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 decreasing. Still decreasing. Now increasing. Okay. Okay, I think that's good enough. Now I have found one solution. And this solution, you see, this corresponds to these values, Z1 and R1. All these values, as you can see, are equal. So what I will do is, this is one of my solutions, Control C. Okay, I have to write beta 2 value, beta 4 1, and beta 5 1. So I'll come over here, and these are values. They are not, I haven't copied anything else. I have simply copied. So Control C, Control V, no. I will simply copy beta 2. Oh, by the way, I will copy beta 2 over here. Beta 4 1. Let me copy beta 4 1, Control C. Divided by dr, so that it is in degrees. Oh, I know it is a huge number. It's okay. Okay, here 22 degrees. Beta 5 1 corresponds to beta 5 1, remember. Control C. I have converted them to degrees. This is one solution. Next, usually what I do is I take these to 0 again, just for the hell of it. Of course, you can continue with not to confuse anything. Now, continue. Look at the magnitudes. There's one easy way, and that is conditional formatting. I highlight less than. Let us say if they are less than 1, make it light red. Of course, you can change this value so that you don't have to, oh, here it is. As you can see, the color has changed. Oh, that's excellent. 10 to minus 14. This is a new solution. Beta 2 is 30 degrees. But notice I have a problem. No, these are fine. Because this corresponds to this solution. So Z2, this goes to infinity. It's there's no solution for over here on the first region, but here it's a good solution. So the solution is Control C. Let me bring it over here. These are the values for Z2R2. Beta 2 is 30 degrees. Now beta for 2 I'm converting it to degrees, and beta 5.2 that's the second solution. And let's continue. Oh, again, a new solution. Let's see how far we can go. Oh, no, it's increasing. No, it's increasing. That's good enough. 10 to minus 5 is good enough. 10 to minus 7 is more than good enough. Okay, now I have another solution. Again, this is, as you can see, the second part of the solution. Corresponds to the, for both cases, it is the second branch. So it will be beta 4.2 and beta 5.2. equal divided by dr equal divided by dr. And then I have to, since these two are the same, I can only copy one. Oh, I forgot. The values only, okay? Let us go on. Hey, I have another solution over here. And let's see, 2, 9. Yes. So ten to minus 4, okay. 10 to minus 6, that's good enough. Divided by dr. I know I can have at most 4 possible solutions, so these are 4 of them. I can pick up any of 2 of those to form a 4-bar. And I'm going to have 6 different 4-bars, which will synthesize this motion. Now, each one of these will correspond to a point over here, but you have to be careful, and you have to, you can, in a way, this is for R1 curve. This is minus 5, 207. That should be minus 5, 207. It should be somewhere outside. This is 1037. 1037 is this point. 5013. 5013 is this point. 7357. 7357 is this point. This point, although it looks as if it's intersecting, it is not. There's another point way up, 207 degrees. Minus 5, 207, that's interesting. Let me show, make it 210. I know it's going to be distorted, but yes. As you can see through the point over here. I have distorted, the shape is distorted, but there's a point over here, 207, where those two curves intersect with the same beta 2 value. This point is not. I can't see that point. And over here as well, you may think that it's, let me repeat, both points, data points, must have, of course, they will have different beta 5 and beta 4 values, but beta 2 value has to be the same for both of them. These are the 5 points that you can locate, and you will have for 6 different 4-bar mechanisms. You can design for 6 different 4-bar mechanisms. This is all. I mean, of course, you can solve the same problem using 5-position synthesis functions, and you can solve it very easily. But this is a very simple way of determining those Burmester points for 5-position synthesis, for 5 positions. Okay, this is all I'm going to talk about in this topic.